Hi, welcome to today's video. Now normally you would expect to see Joey's face here because this is a PS5 motherboard and it's got no output to HDMI. Today is Saturday however, and Joey is off at the weekend enjoying family time. I'm stuck in here not getting to enjoy family time on this glorious Saturday afternoon. But a customer has brought this in. He's a granddad and he's brought it in for his grandson, who he says is autistic and really relies on the console. When we said to him that Joey would come in on Tuesday and do the repair, he immediately panicked and said he really needs it. I'm going to have to go and buy another one. I used to do all of our console repairs on Fridays, so I piped up and said, do you know what, we can probably do this today for you. So I got Mark to disassemble it and I will now take a look to see what is going on. There is no obvious damage inside the port, so there's got to be something going on at the back of the board. Don't know if we can see anything from there. I mean, to all intents and purposes, it looks okay. But we'll take a look under the scope to see if we can see anything obvious. Okay, so my initial thought is the port looks like it's been pushed back a bit. And if we can see the pins, they look okay, but I've got a feeling there's going to be some loose ones. Just because this plastic shroud here, yeah, oh God, look at that, yeah. So everything has basically come off the board, which is why there's no output. Yeah. So that's been shoved back and basically broken the solder, and it looks okay. It doesn't look like it's pulled off any tracks, so this should be just a straightforward repair. So let's get the board on the heater, and then we'll use our heat gun to remove the old port, and then we'll get a new port and put that on the board. So I was going to borrow some of Joey's gloves, but look at the state of that. I know some viewers have had real issues with the state of these gloves, and today I'm going to get some of my own. So the board is just about up to temperature. So we'll just put some flux around the socket, get our heat gun. Should be up to about 450. Just check where it's at. Okay, well, this is all Joey's kit, and used to be my kit, but now it's Joey's kit. And he's got it set to 500, which will mean it will come off quite easy. Now, when you're removing these kind of things, the board requires so much heat. But you must get the socket itself hot, because the pins need to basically detach themselves from the solder, or at least be hot enough to actually detach from the solder. So there we go, that's come off really easily. So what we'll do now is take the board off the heater, and we're going to remove any remaining solder that's in the actual port itself using the solder sucker. If I can just get this located. Okay, so we're going to need the heat gun for this and the solder sucker. Let me get a better picture of what's going on. There we go. Now we need just a little bit more flux. So we'll apply some leaded solder to the port. This is going to help the solder inside the port flow. Okay, so we can see the leaded solder flowing. That should help the solder underneath to flow as well. So let's just give this a go. Just a bit more flux in the hole. This side we have to be a bit more careful because we do have other components on the board that we can jog out of the way, so I have to just be very careful when taking this side off. And there we go. See, I did move a component. Just put that back in position. So we'll just clean up the old solder. Just put a bit of flux on the board before we do that, which will help the solder melt and flow into our solder braid. And if anyone's interested, I only ever use solder braid. Did you see what I did there? I was too busy talking. Okay. Right, we'll just reflow that back into position. Going to need to bring our airspeed down. I'm a bit wrong-handed on this setup because the heater is in the right hand and I like it in the left. Okay, right, that's back in position. That's what happens when you use the big fat tip. We'll swap that over now for the smaller tip. And then we'll prepare the port or the contacts on the board ready for fresh solder because we're going to flow this into position. Okay, so let's just give this a clean. Before we apply any new solder. Clean up that capacitor. Just going to double check that it is solid. Yeah, it all looks good. Okay, so flux. It took a while there for the flux to flow because the board has cooled down quite a bit. So just going to add a bit more flux here. You can see we just got a little join there. There we go. Okie doke, right. Now, I'm going to try a slightly different method to Joey. I am going to only flow those pins there and not the edge pins, and I'm going to solder the edge pins afterwards because I just want to give it a try, actually. Just check that my eyes are not deceiving me. No, they're not deceiving me. I've managed to get some solder in there. So I've got a brand new PS5 port. Just going to check it goes in okay. Yep, goes in nicely. Make sure all the pins on this connector are flush. They look pretty flush to me. We just want this solder to melt so that we can then put the port on, apply a bit more heat. Okay, so let's take a look at what that has done. I've never tried it this way before, so it's always worth looking at what's going on. Yeah, I can see all of the pins are now soldered correctly. We'll just give them a double check. Okay, so that's one side of the actual port done. So we are going to employ our fat tip once again. Now our tip's up to temperature, and we're going to hold it on the port here. And what we're doing here is we're touching the board, we're touching the pins, and I will know when the solder melts on the wrong side of the pin that we have enough temperature to flow the solder correctly. If I put the solder on the iron, it's just going to melt. But in order to get a good joint, we need the pins to be hot. See there? Now that is actually getting hot enough to actually melt the solder, and that will then draw the solder through the board. And you can see, you know when you've got a good joint because the shape of the solder that you leave will look a bit like a volcano. Let's do the same for the others. So we can see there that both of those connections, there we go. So you can see without having to put any solder on this side of the board, the solder has flowed through all the way to the other side of the leg. And that's going to be the same for both sides. You can get a good picture there. So you can see that's come all the way up the leg. And we have, so that means the leg itself has drawn the solder through. So we know it's a good connection. And let's have a look at the other side of the board, look at the pins. So they all look okay, but I am going to go over them again with a soldering iron to make sure that they are super solid. So we'll just put it on the heater, get the board nice and hot, and then we can use our iron to touch up those pins. Okay, so we still do have, looks like 2 shorts there, so let's just get the iron again. So we can see all the pins are solid, so we've got a good finish on that port. Different to the way that Joey does it, not because for any other reason other than I wanted to try it this way. I used to solder these very differently to Joey. I would hold the port in position on the board and then do the ground legs. And then after that, I then solder the pins. But I would always heat the board up. So effectively, we're doing a similar thing, but you know, in a slightly different order. I do think the way that Joey does it is actually quite effective. I just do worry sometimes that the pins on the socket don't sit far enough down on the board and make a good enough connection. So yeah, that's another take on the way you can do this. I prefer the way the ground legs look on this method. I don't really like to see bubbles on the end. If you've got a bubble on the end, you don't know whether you're hiding a good connection. Whereas, as you can see here from the shape of this connection here, it's got the flat point of the pin, and it's kind of like a mountain. It just comes down much like a mountain. If it's a big dome, it can hide a dry joint. So my preferred method is to have these look this way. I hope you enjoyed that. That shows another method of soldering HDMI ports. There's a few ways to do it. My preferred method is ground legs first, but with the PS5, you've got that pesky capacitor right by 2 pins on the back of the port, and it's very easy when you're running the soldering iron across the pins at the back to move it, and then it's a right pain to actually get it back into place, because you don't want to be putting lots of heat on the back of the port after you've just soldered it on the board, because you might melt the plastic and then you get, not as pretty a finish. So we're going to take this downstairs now to Mark for reassembly, and then hopefully all's good and we can get it back to the customer. We'll take a look in a minute, see what the results are.
Sean has passed me a PlayStation 5 motherboard that doesn't have any power. I've done some extremely basic checks. We have 12 volts coming in, and I've just been probing around the board to see if I can find any shorts in some known places that I know of from past experience. If I head straight over to the back of the Wi-Fi IC, the Wi-Fi IC itself is on the other side, if I just show you. So we've got the Wi-Fi IC here, and if we turn it back over, this is behind that. And you might be looking at something already which looks a little bit weird, and it's this cap here. Now, if I measure this cap as well as a few others in continuity mode, I seem to have a short, but it's not all of them, it's only a few. My suspicion is that this cap here is faulty, but just because it looks bad, that might not be the case. This cap, this cap, this cap, and this cap are all shorted to ground on the path that leads into the IC on the other side. So I'm just going to inject a small bit of voltage here. I'm going to start with like 0.3 volts and just see if we get any sort of amp draw. All right, here we go. What do we get? So 0.3 volts. We get 1.2 amps being drawn, so something is getting hot. I could use a thermal cam to see which cap it is. If it is any of these caps, by the way, it might be something else on the board, or in fact the Wi-Fi IC itself. It's not evaporating straight away, and exactly the same story over here. Okay, so we move over. I'm just going to keep this one here in the loop and see if that does anything with the IPA. Injecting now. Okay, yeah, I think it's that one. If we leave it, look, you can see that the IPA is slowly evaporating from that cap. I'm going to go ahead and just remove this cap and see if that alleviates our short. There we go. Soldering iron there would have probably been quicker, but the cap's off the board. Meter back in continuity mode. Do we still have our short to ground? No, we don't. It's all gone. Okay, so that should fix this issue with this board. Yeah, our short is no longer there. What about on this cap? No, short is gone. I will need to replace the cap that was here, but that's really good news. Tiny bit of flux. And just prep the pad. Here's our replacement cap. Back on the board like nothing ever happened. And if we measure on this side of the cap, no short. So this side is ground, this side, no short to ground. Perfect.
So I took the PlayStation down to Mark to reassemble. After reassembly, tried to power it on, nothing. Pressing the power button a few times did elicit a beep, but that was it, nothing else. So I brought the board back upstairs, have a good look at the board itself, did see some traces of liquid metal on the board, cleaned all of that up, reassembled, took downstairs again, tried to power it up, nothing. So I brought the board back upstairs, did a look at the board for any obvious damage to components or anything like that. There was nothing, untoward at all. I mean, it's a pretty straightforward process doing the HDMI port. Apart from components getting moved around, it's pretty straightforward, but it's all localized to the area that you're working on. So I tried to do a bit of voltage injection to see if I could notice anything, but it was getting late in the day and I had to go, so I left it for Joey to do. He's coming on Tuesday. Found the source of the problem, which is a single blown capacitor near the Wi-Fi IC, sorted that out, and now the PlayStation's fully working. And the good news is it's back with Grandad and back with the grandson, who is now very happy to be playing and communicating with his friends again on PlayStation. I hope you enjoyed that one. We'll see you again in the next one. Thanks for watching.